In Optica, we are told that what our corporate engagement council tell us to do, and they told us to do this event, and we hope we made you proud. Simon Schwinger, corporate member of the Corporate Engagement Council, the floor and the attention, everyone, is yours. Tell us what's going to happen now.
Thank you, Jose. You see, the next topic of the agenda is bringing photonic innovation to global markets, and especially talk about marketing and scaling innovation. I'd like the panelists to come up front to the stage and join me. Thank you. And we kick it off with each one of you. Please introduce yourself to the audience. So maybe to kick it off, Luis, you want to start?
Yeah, well, thank you very much. It's a great event. I'm very happy to be here. I'm Louis-Rafaël Robichaud from Quebec City, Canada. I'm the co-founder, CEO, co-inventor of Femtum. Basically, Femtum, we develop advanced laser solutions for semiconductor laser processing. It's based on a unique IP we developed in Quebec City. So we build ultra-fast, mid-IR, so 3-micron fiber lasers. And it happens that you can do now multi-photon absorption processes, which enable really advanced semiconductor laser process. So I'm very happy to be here and happy to discuss.
Thank you, Luis. Philipp?
Yeah, so my name is Philipp. I'm from Keystone Photonics from Germany. Yeah, we're looking over to Spain with a lot of happiness, actually, to see that there's a lot of investment in photonics. So that's part of the reason why we're also very interested here. We're doing wafer-level testing. So exactly what Global Foundries just asked for, and that's what we're here for. Thank you.
Well, thank you very much. Jean-François?
Yeah, nice to meet you. So I'm Jean-François, I'm CAILabs CEO. CAILabs is an 11-year-old company, 120 people. We do laser communication from ground to space. So we do the focus on the ground stations, and we're based in France and the US.
Wonderful. Brian, would you please introduce yourself?
Peter O'Brien from Tyndall in Ireland. So I represent the pilot line in packaging. So it was really interesting to hear the comments from Global Foundry about the challenges of packaging, because we can elaborate more later, but without a shadow of a doubt, there's a lot of work to be done. And I do really believe, that alignment with the semiconductor industry is the way forward. So we can get into more of that in a while. Thanks.
Thank you, Peter. And Jimena?
I'm Jimena García-Romeu from Alcyon Photonics. We do integrated photonics design IP, so part of that ecosystem that Global Foundries just mentioned, because our goal is to make photonics come into large scales. And so we think for that, we need to make these building blocks, these PICs that anyone can use at the foundry, fully reliable, that NVIDIA mentioned also just today.
Last but not least, Atul, pleased to have you on the panel.
Quite a while back, early 90s, late 80s, early 90s, I used to work on optical communication systems. So those were the heydays of the competition between Philips Research and Bell Labs on who can hit the bit rates early. So I was at Philips Research in Eindhoven. Subsequently, it led me to think, hey, what the hell, who wants to use all this bandwidth we are creating? So I moved on to work into processing and applications and user experiences of usage of the bandwidth. Created a company doing parallel processing, which became quite a big worldwide venture, scaled up. We became big by applying our processors for cameras when cameras took off in the mobile phones from 2005 to 2010. We were quite a name in the industry as the only software-defined camera. Became boardroom talk in Silicon Valley, got acquired by Intel. Spent some years at Intel, and I said, well, if we could scale up and build living in Europe, then so can many others. So after leaving Intel 2013, last 10 years, I've co-founded 4 companies, been on the board of multiple companies as an advisor. Around 10 companies I've worked with as ventures in Europe and US. Quite diverse, deep tech, but most of them are around computer vision, machine learning, AI, the applications thereof in autonomy, in robotics, but also implementations thereof, semiconductors. So that's my background. 6 of the companies we have sold with good returns. Some are still there. And I was sort of trying to hang my gloves and say, hey, am I done? And I got a call from Miguel and Javier of Bullnet saying, hey, maybe you should get back to photonics. So I came down to Malaga, met Professor Inigo Molina at the university, got excited about what he's doing in silicon photonics, and there I am.
Wonderful. Thank you very much. I'm very pleased to have this breadth of expertise here on in the forum. What I would like to start with my professional life, I spent primarily in optics, photonics, but not only, I've been exposed to other industries as well. Looking specifically at photonics and compared to other deep tech areas, what are so specific in terms of requirements for photonics to scale and to market? How do you feel? Louis?
My take is that, it's an extreme sport to be a photonic entrepreneur. So you have to learn everything about everything. So it's a super deep tech. You need to understand photonics, electronics, mechanics, thermal. But aside the technology, it's you need to commercialize globally. You have to find your application, your niche, and what you are very good at. So your product, let's say your product strategy, needs to be very thorough. But you really need as well to have like this technology that can make it happen. So to me, photonics is really an extreme sport, and you need to be out there, a bit hustling with people, especially as you are in this power play with the giants, and you try to convince the giants, and you're like, it's David versus Goliath. So you really need to be out there and tackle specifically and be super strategic in what you're doing.
So I strongly believe that the key for scaling in photonics is to be able to cope with the diversity or the non-standardization. My personal view is telling photonics people to standardize now is like telling the French to only drink one wine, or to the Germans like only drive one car, or Spanish only eat one food, you only get one jamón. No, that's not going to happen because people see value in the technology, and that drives the variation up. I mean, the performance is a key differentiator of many photonic components. So for scaling, one has to tackle this diversity, and that's basically also part of why we do what we do. Keystone is super flexible in adapting to the different variation, to the different requirements. I mean, all these test requirements that the different foundries have, a reasonable fraction of them comes to us, and we design products for this. We're super flexible on 3D printing, new types of optics, and solving wafer-level testing challenge. So that's what we do. We can cope with this complexity, and I think that is what one needs, dealing with complexity or dealing with a diversity of the photonic system.
Yeah, go ahead. Thank you.
I think my point on that is probably the position in the value chain. In our case, we are optical components at the beginning, some good stuff there. But then we realized that in order to get our good position, we need to go up in the value chain, which is like photonics plus the rest. And this is actually driving growth really fast. So I think it was strange. We got to a more complex product, but in the end, that was far more volume.
So when you mentioned that it's component compared to a higher education system?
Yeah, exactly. So basically going up a little bit in the value chain. I think one of the elements is that some other elements of the value chain may be already commoditized. So you can actually integrate that, make a larger product, basically. And paradoxically, this actually allowed us to go much faster. So basically, the bottleneck was the integrator. The bottleneck was not. So that was interesting for us, and that actually took us to the market much faster.
Thank you.
Strange.
Yeah, so I think there's two key things here, from a packaging perspective at least, and I think you should be convinced from the previous presentation the challenges around packaging. So the first technical challenge is that, and I've been saying this for a period of years, I suppose, working in packaging for the last, say, 15 years or so, at least the optical packaging, things like edge coupling are really just, archaic. We need to move to the surface. We need to do similar electrical style packaging. And I suppose the challenge from a packaging point of view is that that's done in the foundry. And that brings me to my second point. The ecosystem often is very fragmented. So when the chips come out, we get them, and we have to deal with that. So how do you scale? You can't. You can't really scale. You can't scale edge coupler packaging. It's very difficult unless you have lots and lots of machines and you do it in certain parts of the world. So for example, in Europe, if we want to do this, we're going to have to come up with more innovative ways. And that really is around more automated, machine vision, surface level type coupling approaches. It also means that we need to work closely with the foundries. So for example, discussing with the foundries where they locate their waveguides so we can actually access those waveguides. So I think some of it's fairly straightforward. It just needs better communication. It's kind of jumping across the barriers. Because when we started packaging, we just got chips. We didn't know where they were made. We didn't know what the mode size was. Even the people working with the chips weren't exactly sure. It started to change a little bit. One of the things with the pilot lines that we've learned, because we had a small pilot line, relatively small, there is an initiative now for a very large pilot line, that especially working with smaller companies, startups and the like, you can orientate them very early on so they have a direct line of sight to manufacturing. But one of the problems is that the OSATs are not ready, in particular the OSATs. So preparing and collaborating with the OSATs is very important. So we developed the PDKs and what we call the ADKs, the assembly design kits, that they're ready, that we develop a process and we can transfer it quickly to those OSATs. So it's all compatible. So that linking of the ecosystem is very important. And as I say, we're currently developing solutions which are edge coupled and so forth. They're not ideal, but it's the only thing we have right now. But we also need to be looking at these more surface level packaging approaches. So I think it's really kind of opportunities like this to pass that message out, and kind of the technologies are kind of already there. It's just we need to gather them. And I think that's really important. The last thing I'll say, just on the pilot lines, they're very good for, when we started looking at this, it was very much industry orientated. So how do we help industry scale? But it also helps research organizations ensure that whenever they're developing new technologies, we can help them orientate what they're doing and their approach to be more compatible with scaling to higher TRLs. So, I'm here to kind of like promote what we do and to kind of a call that we collaborate more. But I do think it's a very important initiative. I think Europe has been very successful in that, and it's beginning to happen in other parts of the world. But that kind of standardization, collaboration of the ecosystem, and new technological approaches built around what's already established in the electronics world, I think is very, very important.
I think what you mentioned reminds me of what Greg just said, is the ecosystem, understanding the ecosystem and managing the ecosystem.
Absolutely. I will say that companies involved in packaging have great respect for, because really it's really a day-by-day effort. You don't know, in a sense, what chips, like today we're talking about silicon photonics. There's also indium phosphide. There's many materials, there's different mode sizes, there's different RF performance requirements. It's a real challenge. So people involved in packaging today, especially the commercial companies, have great respect for them. And hopefully we can kind of collaborate more and make life a little bit easier and more profitable as well. Yeah.
Thank you, Peter. Jimena, what's your take?
Well, we acknowledge that this is a very fragmented market in terms of future applications, in terms of packaging, materials, and so on. But when we are talking about scaling, we are talking about volume. That's how it's named. So, as you mentioned, quite often you find yourself in a position where you need to know about what's unique to you, but about many topics. So I think this is a very difficult situation for the industry in order to adopt the next value chain technology that is needed. So as much as we can work in building more, won't call it plug and play, take away technology to others, whether it's IP, whether it's a standardized packaging, and standardized doesn't mean that an organization needs to set it, that you cannot come with a number of potential fits for whatever the products are. The easier it's going to be for all of us to get into the volume, the easier it's going to be for all of us to get more efficient and better at what we are delivering. Also, the yield and the repeatability that the large volume players need for the application. So I think it's also our responsibility to come with ideas that can be very easily adopted by others, and that can apply to, maybe it's a question of not one size fits all. Maybe we cannot have 1,000 SKUs, that's impossible, but maybe we can define ourselves as a companies, a set of game boxes for every application we want to target. So,
Thank you. And Atul, from your experience, what do you think?
Well, to me, I'm about re-entering photonics. I don't know the details and specificities what you face today compared to when I was in it 30 years back. But the more I spend time here and try to understand, I don't see much of a difference between what you are facing here compared to any other deep tech industry. From my experience, to build and scale a venture, what you typically have to do is something more than what you do already. And that's the key. So, and I think Jean-François made that point earlier, saying his experience is going up the value chain. So let me address that point, because that's one of the key topics, I think, to scale ventures, which I have practiced very well in the past. So in my own company in the past, in camera space, we started as a processor company, and we verticalized this company, saying, hey, there's a processor. We acquired companies who had camera knowledge to put camera software on it. We acquired companies in Asia to do computer vision on top, such that it became a solid camera which people can just start using in the industry across silicon and OEMs. And that's what brought scale to us. So in my mind, I think you hit the right card saying, hey, scale, here was an example of verticalization, how you scale, but also I've been through examples where you horizontally scale, that's possible too. So for instance, in companies that have worked on machine learning perception software, you just can't sell machine learning perception software, doesn't matter how good you are, because you also need software to generate synthetic data to train. You need software to capture data to train. So you typically go and horizontally across the spectrum and do something meaningful for an end customer. So in my mind, my learning is across 10, 11 ventures. Every venture that wants to scale in deep tech has to always do more than what it started with. And that's the key. And to do that, you have to go out of the box, maybe do M&A if you don't have the knowledge. But to wait saying, I don't know, and someone as hypey is not telling me, that doesn't fly. Right. Because of course no one will tell you. You just have to go and acquire them to consolidate. That's the only way.
Good. Thanks for that. So what I sense is it's possible to address the different points of what to be aware of before you scale. When we now get to the point and say, okay, product is ready, I've industrialized it, I want to really scale and take it to mass production. Have you made experiences? What are necessities to get across that line and say, okay, this is now done, it's ready for mass production? Anyone can pick up the question, or we go one by one.
I have a comment because there's a lot of silicon photonics talk, and we are not buyer of silicon photonics, we consumer of that, and then we put that in a larger product. And to be clear, on our side, our vision is it just doesn't work. So the yield that we get, and we're supposed to get a final product, and we actually have, there's so many rejects. So the good thing is, because we are up the value chain, we can absorb a much more expensive silicon photonic stuff. So it's okay. You know, we can still make a business out of that. But clearly, we are, at least on our perspective, we're really far away from the volume we are talking about. And one of the big challenges we've had in terms of product maturity on that side is we met with foundries, and we had all these foundries, and then supply of PIC, and there was I think probably met all of them in Europe, and we bought quite a few of those, and there was not an honest or there was a mismatch between what they were telling us in terms of maturity and what was really available. And I think that mismatch was a kind of it took us time to get through, and now we are far more pushy towards those discussions. In those discussions, it took us time, and we are quite disappointed with that. And so the challenge is, if it's a research center, then tell me it's research. Tell me it's something new. Tell me you haven't done it before. And if it's actually production and you've done it 10 times, 1,000 times, I'm happy with that. Just tell me results, and I'm good with that. I'm going to pay for that. But it's like always mixed.
So be clear about the TRL, the maturity level. And
be clear to the client, and this was me as a client in this. And of course, we try to do the same with our own clients. Right. Be very clear of where we are, and have them visit, have them test, have them see what we are doing. Today, we can absorb this for PIC, but it's a challenge.
Thank you.
Sorry, long.
Yeah, so we're continuously looking at things we can improve and do better in early stage pilot development. So just to be clear what we're talking about here, it's essentially bridging from early stage research, and that could also be within a company, to transition to more manufacturing. So areas that we've identified, not just technical, because I mentioned one or two things about coupling and so forth, but it's also models, cost models, for example. We've had situations where we've dealt with users, companies, where they're asking, are we making a good choice? Because as you've seen, the packaging costs, for example, are a large portion of manufacturing costs. Plus, you may not be able to manufacture it because it's so expensive, or the equipment or the materials are not available. So developing a cost model is something we really now are focused on. We're collaborating with one or two other groups who've developed cost models for other manufacturing industries like the automotive industry, and bringing our knowledge of parameters, of materials, of process steps and equipment costs and so forth, and to help develop those. Because sometimes people say to you, and I think this is a very wise decision, rather than going in and saying, here, build this part, develop a prototype, and we'll see where we go from there. Really, kind of what I call it a paper study, theoretical study is very important, very valuable. So rather than kind of just investing in getting chips made and then pursue, where do I go to get all this assembled? Do an investigation on the actual cost of the manufacturing, and actually if there is a manufacturing route, because for a lot of this there isn't. It's not scalable. So as I said, that kind of modeling is very important. The other thing that's very important is reliability. It was mentioned. So for smaller companies, they may not have the resources, or there's not a service. So that's something as well that we're developing up, because especially with materials like epoxies, optical epoxies, they're really, we have to eliminate them. They're long term, they're not a viable solution. So things like the pluggable optics, and again, if we can go to the surface, we can use solders and so forth. So that's something to be developed. But reliability is another very important aspect. So, you might develop a process, but it's so complex, is a reliability issue. And these are things that need to be considered and all taken into account. But that kind of principle of a theoretical study before you ever plan to do anything, I think is very valuable. It can save a lot of time. It can save a lot of, obviously, a lot of cost, and can possibly help accelerate your development process.
I think it kind of fuels the discussion we had prior, how much time it takes to really get to market and to get into position to scale.
So I have a kind of different point of view on that. So I think PIC, design, reliability, yield, very challenging. That technology, very expensive to build. Startups, it takes a very long time, very large investments. Let's say, if I look at fiber laser technology, which is like bigger, we can assemble it by our hands in Quebec City, have high yields, go to market. If I look at the story of Femtum, we started, let's say, from year one, making our own products, manufacturing our own product, delivering our own products. It was not like based on machines, advanced designs. We have our own, stuff. And then you have like even on the photonic industry, like the people that make the machines, let's say the Ficontech of this world. So to answer your question, let's say, how do you go to market when you have, let's say, a fiber laser technology at this level? Then I think it's really going to strategic partnerships. Let's say we are partnering with Ficontech, so we are going to develop a shared solution together to address the PIC challenges that you are referring to. But at the end, to me, every photonic product has different challenges, different business models. You really need to adapt. There's a lot of PIC discussions, for sure. But I mean, I see a lot of people from spectrophysics, current, like fiber laser guys. I see other guys making the machines here. So I just want to keep the discussion pretty broad. Like even he makes the probes, and then right now he's having a bootstrap, super nice technology, super nice business. It's going very well, and he's solving a very critical wafer level testing, let's say, problem in the industry. So I mean, there is space for a lot of different, let's say, product and business model, I think.
Yeah.
Maybe comment now. The original question was on the time scale, how that it takes to develop photonic systems, and I'd like to link up to the previous comments there. I mean, it feels often very, very slow, and we have to ask ourselves, why is it going slow? And in many cases, I fully agree to your comment that there is no honesty about the maturity stage about a certain technology. So if you buy a photonic chip from a foundry and you're not getting specs for the mode field or the coupling efficiency or something like this, it's like buying a car and you don't know how fast it goes. I mean, you would never do that. I mean, sorry, German, I talk about cars a lot. So I think having this specification, having testing in every step, and being honest on how sure that particular property is, like, for example, coupling efficiency or variation or whatever, that is super important. And doing this, being very honest, being very systematic, going in small steps, that will definitely speed up things. So I think that is one of the most important things that we learn to go in small steps, but solid steps.
Thank you. Atul, Jimena.
I think maybe from our side, it's kind of related to what you mean about when you get a peak, you don't have enough information. That's one of the things that we are solving, and connecting with what you do. We see that kind of players in the industry, whenever they build a product, they send a sample for someone to test it, because I'm outsider, seems like they don't trust that manufacturer. So one thing that really surprised me, and I think it's something about building an ecosystem, is foundry have a process, big designers has a process, there's people who's doing testing, and it seems like since everything is done in-house, we need to prove outside that the data is reliable, that someone has to do again the testing. Maybe it's a way of collaborating. I do the peak, someone fabricates, you do the testing. So we can show externally that what I'm doing, what I'm saying is the same thing. So I think this is the other way around. It's an opportunity for everyone to place a strong position and its strength in the value chains and build a more stronger ecosystem, making the reliability connects and flows all over the value chain. So one of the things that I was wondering from test houses or test companies such as yours, could you be the one that states that the peak is well done? Why don't we start working that way as an industry? Because again, I agree with you, it's completely unacceptable that the data you get from a peak is not sufficient to run a minimum simulation, or it's not reliable and it's not consistent with the actual performance.
Mm-hmm. Thank you. I'd like to listen to Atul and then we get
I'm thinking of, see, if there is no demand and there is no momentum, then things just waver around, okay? But when the market takes off, see, scaling is a lot about timing, right? It's about you scale when the market is about to take off. Before that, you get killed, you burn too much power. Do late, and you are taken over by your competitors anyhow because winner takes all. So scaling is a lot about timing it properly. And when you time it properly and the industry momentum takes off, I can tell you there is no time to talk about reliability and testing and who does what. No one has time for all that. The only thing the industrial partners then want is one-stop shops. Who can give me what I want? You figure it out. And that's the way the industry works in every momentous cycle. And I've been through one, I said the camera, I've been multiple actually. And when the camera cycle took off, I think Sony played the best game. They said, we'll become the one-stop shop. And you can see the result, right? Sony took its camera sensors, they took all their processing software knowledge, they took all the foundry knowledge, they even did integration of CMOS with logic chips, the package. They did the module for Apple, and that's the name to fame for them, right? If you look at the 10-year financials of Sony, all profits of the company came from this one particular bet. So that's the point about scaling, and the same holds of ventures. So if you want to scale, you got to time it, and when you time it properly, and let's say you are the winner, you got to be the one-stop shop. No one has any time to talk about anything else. And actually, that is what I was talking about today at one of the breaks with Ashkam from NVIDIA and Johan Feenstra from Smart Photonics saying, well, that's exactly what will happen in this industry. That is, when some mover and shaker at NVIDIA says, I want this, someone has to just go and do all that's needed for them and not talk about all the problems. There's no time to talk about problems.
And I think that there are companies out there, the classical CMs, that operate exactly like that, but they assume, and they must assume, that everything is fully developed, and they just go execute and start building stuff. And if
they will just bet on who can be the one-stop shop for them.
Right.
There is no space for anyone else then.
Yeah.
But isn't that a contradiction to what Jimena said just before about the collaboration between different companies and the one-stop model? I mean, you're basically saying two different things.
Not really. The collaboration is all in the back end. Fine, great. Collaborate or merge or whatever, but be the one-stop shop as a front end to your customer.
Okay. Fine.
I think we got to speed up. There's a question, please.
Hello? Oh, thank you. Darren Burns from IDEX again. I'm going to be the guy who drags us kicking and screaming back out of the PIC world for a minute, because I think there are a lot of us here that are still making products that aren't PICs, and maybe someday we have to get there. And I look at the title of the group here, Innovation to Global Markets. So maybe the challenge to you guys, and thank you, Louis-Rafaël. Did I say that right?
Louis-Rafaël, yeah, no problem.
For bringing up kind of something that's not PIC related and trying to open the tent right to the larger group. But maybe either some of you could comment on this issue of, based on the content of the rest of today, right? How do we take innovations in either laser technology or innovation in communication technology, and really drive that into this global market idea, where we know there's all these limitations along the way to do that? I mean, maybe you can speak from your own experience. I know, like in your case with CAILabs, you guys have had a beautiful technology for a very long time, right? And have looked and eventually found, I think, a pocket where it's really providing unique value. But maybe you can speak to that, and maybe you guys can as well. Thank you.
Yeah, I think I see what you mean. For us, it was the recognition. It was 2021, end of 2021, just after COVID. We were still trying to sell the optical stuff. And we had a good optical stuff. And then we were looking at integrators. And there were nobody was interested. And then we went to we were lucky, because we were in space market. It was relatively easy to access the clients of the integrators. And the clients of the integrators were extremely frustrated, because the integrators were not doing anything. So they were saying, we need that, and in between there was somebody who was just sitting on their hands, basically, not doing anything. So we were lucky, because there was a room in there. I mean, if we had a big integrator in the middle, we probably wouldn't have done that. There was nobody doing it, so we had a little head start that enabled us to grow. And then the other side was getting the means to do that, so raising capital quite significantly, because you transform the company to actually do that. What's interesting is, when you start to do system level or integration, it's like the electronics, mechanics, all that stuff. Like you can hire people from large companies, and like it's not as complicated as what I thought earlier. So it's like, if it's commoditized or relatively commoditized, you can scale that up without too much trouble. That's kind of the learning there. And now we are on system level. And system level is a bit more more comfortable in our case. So I think that's what happened. We were lucky. At that point in time, there was no big competition on the integrator side. I wouldn't be able to say what would have happened if we had a massive competition at that level.
I have a very similar story, actually. So, we built this techno-push, 3-micron femtosecond fiber laser technology. We sold to universities and many very niche markets. But what happened during COVID is that a very large photonic foundry reached out to us because they had like this yield problem. And then it's like, who is going to solve this yield problem that they had? And it happens that we built also our process, let's say, capability in-house. So we have like micro machining stations and whatever. So we built this expertise at the process. So now we have like IP on the process, because people don't care about the laser, don't care about the system. They care about the dies or the PICs to be delivered in time. So actually, it's process. It's a lot about the process. So for us, we did exactly the same. We now offer let's say the system, so which is like the laser, optical LED, like the IP, the process, also the software integration into the real machines and to the real semiconductor tools. And then we stop there because like bigger than that, like making the full wafer tool, we cannot do this. So at this point, we can bridge that gap, but then we need to partner up with, Ficon-Tech and like the Ficon-Tech of this world that can really deliver a full solution to someone that tried to manufacture a PIC, for instance. So, and for us, it's really very analogous to what you say, actually. So, and then we raise money because fiber laser technology, easy to do, let's say, yourself. But then when you try to do a semiconductor wafer laser processing, you need a lot of money. So then we raise money, and that helped a lot, and we grew, and now we are, executing a lot. So there's a lot of challenges, but I mean, your point is pretty valid.
I like the energy here. Just one more comment, then we have Sven with the next
So
one.
basically, what you mentioned, bringing innovation into market, is what moves our company and the way we want to make it, and that's why we also say about making very easy photonics. So the way we're doing, and it's, again, we were born on patents, know-how, again, raising money, starting validation, demonstrated works, small scale, raise more money, demonstrated works at the bigger scale, the technology, and it connects with some of the conversations that I've had today. There is a clear need in market to accelerate the adoption. So we are seeing some IP players rising, same as us, so we have competitors at last. So next step, obviously, for us, not public yet, is that we are collaborating to build that ecosystem where no one in this industry needs a PhD to build an application. Because same as semiconductor was mentioned before, there is people that is reaching faster innovation to market because that was their specialty. It's building these peaks in a reliable way to build something upon. So quite a different story for the time being.
Can I add a comment? Small. So bring innovation market. I think there was a nice slide shown by Edwin Rooks of Teledyne in his presentation earlier today, wherein he talks about going all the way from his sensor up the chain all the way till the end user to learn all the requirements. In the end, he learns that, they want their system-level IP to be designed into my sensor such that there is protection. So it's a nice example of when you're trying to bring innovation to the market, you better traverse mentally or in the lab the experiment of taking it all the way to the market, to the end consumer, learn from it, and come back and see what is it you really need to deliver, because you then probably meet a number of requirements down the value chain, and you have a better product to the market.
Agree.
We're getting towards the end of the session, Sven.
Yes, and this is actually Sven Kionka as Ferricon. Darren, thanks already for the direction, and I want to go even further that direction. You addressed it already. When you have components selling already for a long time, or technology or whatever, when you want to go for the next step, maybe you did 2 decades, and now you need to adapt to what's happening in the world. Yeah. How do you find your next vision? How do you go for it? How do you know that this is what the customer needs? Now, when you're very close, it might be easy, but when you want to go for the next step with your company, maybe you're 50 people, but you want to be 500 in 10 years. How do you find the next vision for you and where to go? We have a little bit seen from you what you do. You buy and buy and buy and go somewhere. Maybe you're right, maybe you're wrong sometimes, right? What would be your comments? Huh?
We are not there, but my question is, do you have a dream? I do have a dream. I want to be photonics in any device in the world. And I know for that, photonics needs to be easy. And I know for that there are different applications I need to be serving on different processes, but maybe also on different materials. So I have a roadmap. I'm still starting on the scale. I move from there.
My view on this is that, before I was really focused on the product, and now I'm very focused on the people. So building let's say, the real relationship with the right partners and the top guys. So like to really find like the next market, you need to be at the table with the right guys and the right customers and really understand in a genuine, transparent fashion what they really need. And based on that, if it's massive opportunity, then you pick a lot of data points, let's say, of talking with many of the people. if that makes sense, then you move along. But I think you need to be like face-to-face with the customer as most as you can. And then you derive also, you know, these events are very great, thanks to Optica, because now we are, let's say, together, we can make these connections. But that's, I think, super important. The people is the, say, the art of this industry.
Thank you. There's one more question in the background.
Yes, so one more from my side. Johan Veenstra from Smart Photonics. So first of all, I completely concur with what Atul just said, and also that it's not contradictory, right? Because in the end, you want to face to the customer, you want to solve their problem, their full problem. And I've had, unfortunately, many examples where, you know, you deliver a chip, or you talk about delivering a chip, and they say, well, you know, I can't do anything with a chip because what's next, right? I mean, I have to have the end game. And having that bridging that gap is quite difficult, but you want to do it for the customer. You don't want the customer to actually give that problem to fix it by themselves. One other question, or one other problem that I face regularly is the chicken and egg thing here, because we're not talking about development times of a week, right? I mean, we're talking about long development times. So quite often, and especially when you bring innovation to global markets, you know, when you need the volume, you would like to actually see it already at the start of the development process, but that's actually something which is not there to begin with, so you need to get people on board that trust you, that you will get there once you've done this long development trajectory. So no, I know how I deal with that, but you know, with all of you and all the experience on the podium, I'd love to pick your brain and hear how you deal with this chicken and egg issue and how you solve it.
So I think it's always a risky business. So not just for ventures, but even for big corporations to bet on something new. So that risk-taking capacity is, and the elements are always there. You can argue that if you don't take the risk, then you'll be taken over by your competitors anyhow. So I think, and yes, it is a chicken and egg problem. And you cannot get commitments, but you also know that if you don't take the risk, then you lose anyhow, so why not take the risk? So, and there's a convincing going on between your customer, yourself, your supplier, your investors, on what is that risk you're taking, right? And you can play that game very transparently across, between the supplier, yourself, your customer, and your investors. And if you play transparently, then a lot of things come on table, and people understand what's a calculated risk. And then they can even trust you to take that calculated risk. But you got to start that discussion, what's it about?
Couldn't agree more. This goes into the direction what you mentioned, that there's sometimes not enough transparency. Not to say they are lying, but not enough transparency where they are in the maturity stage. And just discuss about it, right? And to keep this open, and then more ideas evolve, how to manage risk, quantify the risk, and then work with it. Jose, how are you? Are we good in time still? Or?
That was a great panel, right?
Thank you
so much for a great discussion.
Talk to your team for collaboration.
This is the last coffee break, so make sure that you talk to everyone you can still do business with. When we come back, we have James Butt and John T.C. Lee back to back. It doesn't get any bigger than this. Use it. Until the next time. Video up.